friends, welcome to my YouTube channel Civil Engineering Hub. This is a second part of video regarding steel estimation, and in this video we are going to learn that how to calculate a length required for bent up bar and for straight bar. So before going to the calculation, we will understand that why bent up bars are provided in slab. What is the need of bent up bar? So let's start. As you can see in this figure that whenever we apply a load on a slab, the slab will try to deflect in downward direction and it generates sagging moment. But at the opposite end or at the support, you can see that the moment of the slab is in upward direction. So we call it a hogging moment. As you can see in this figure, we have one continuous slab and we have 4 supports. So straight bar will be provided over here and bent up bars will be provided like this. Now we can easily understand that why few amount of steel is placed in upward direction, because it generates hogging type of movement, and to resist that movement we required some steel at upward direction, and that is the reason bent up bars are provided. Right, so these are the regions where you can see bent up. As you can see in this figure that bent up bars are provided at 30 degree or at 45 degree. In addition to that straight bar length, we need to add 0.3 times D if the bar is bent up at one side, and if the bar is bent up for both the side, you need to add 0.6 times D. So for 1 times 0.3 and for both the side bent up, that is 0.6 D. Similar way, if the bent up bars are provided at 45 degree, you need to add 0.45 D for one side bent up and double of that, that is 0.9 D for two side bent up. Now most of the students get confused between this D and diameter of bar. So as you can see in this figure, that D that we are using over here is not a diameter of bar, it is a center to center distance for a bar which is bent up. Right, so as you can see that now this bar is bent up from top to down side, so it is a distance between center of this bar to the center of the same bar which is bent up in upward direction. So in short, we can say that this much distance is going to be D. So in next slide we are going to see that how to calculate the distance, that is D. As you can see in this figure, one bent up bar is provided, and here suppose in your data the slab length is given. You can consider any length, that is 15 cm, 12 cm, etc. So in this slab length we want to reach up to the center of the bar. So you can see that for this slab, first we need to deduct the top cover and bottom cover. So after deduction of top cover and bottom cover, we have reached up to the surface of the bar, but still we want to reach up to the center of the bar. It means we need to deduct half diameter from top side and half diameter of bar from bottom side. As you can see in this slide, if you want to calculate D, the D is equal to slab thickness minus top and bottom cover minus 1/2 diameter of one side and 1/2 diameter of bottom side. It means we need to deduct a 1 full diameter of bar to get the value of D. Now before calculation of D, you must know what is the top cover and bottom cover values. So for slab like structure, we are generally using top cover and bottom cover as a 2 cm for calculation, and for slab the side cover or end cover, you can see, you can consider it as a 5 cm. So the length of the bent up bar will be, now see, the hook is compulsory in all the bars. If we are calculating the straight bar, then also there will be a hook. If we are calculating Bentup bar, so hooks will be definitely provided at the ends. So total length of Bentup bar is equal to length of slab minus 2 side cover plus 2 hooks plus additional length required for Bentup bar. Now why this additional length is required? So if you draw a straight line, suppose this bar is going straight, and by taking this much distance, if you put a radius of this much additional length is required for Bentup bar. It means the steel that we have cut for straight bar, we cannot use the same length steel for a Bentup bar, and that is why this calculation is required for a Bentup bar. Let's start with this example. We have slab depth that is 15 cm, main diameter bar that is 12 mm, distribution bar that is 10 mm, and slab diameter that is slab size that is 3 by 4 meter. So main bars are always provided along the shorter span of the slab, and distribution bar are always provided along the longer span of the slab. So in this figure we can see the shorter span is clearly visible, as you can see the straight line which represents the main bar. So the length of main bar, which is straight, is equal to shorter span length. So we have length of the shorter span is 3 meter minus side cover or end cover. So now you know that we are generally considering 5 cm as a end cover or side cover. So we have two sides, so I have deducted here 2 into bracket 0.05 plus 2 multiplied by 9 times diameter of bar, which is a formula for hook. So after calculations we are getting 3.11 meter as a length of straight bar. Now it is but obvious that the length of Bentup bar is going to more than the length of the straight bar. Now you can use this as a cross checking, right? Whenever you are calculating the example, and if you found that the length of Bentup bar is less than straight bar, definitely there is few mistakes in your calculation. Let's calculate D. So before going to the calculation, first you required a depth of the slab. You must know the range of top cover and bottom cover and diameter of bar. So here we have 12 mm diameter and slab depth that is 15 cm. So we will deduct 15 cm minus top cover minus bottom cover minus 1/2 diameter of top bar and 1/2 diameter of bottom, because we want to reach up to the center. So the results or the answer we are getting, that is 9.8 cm, but all the values we have calculated in meter, and in our formula 0.9 D we need to put the value of D in terms of meter. So we have converted that value into 0.098. Now to calculate the length of the Bentup bar, you can easily go for a simple calculation that whatever the length we are getting for straight bar, you can add 0.9 times D, because only the hook is an additional member. So the length of the Bentup bar, that is equal to the shorter span length minus 2 side cover plus hook or plus 0.9 D. So as you can see in this figure, we have 3 meter distance of shorter span minus 2 covers plus both side hook, so 2 multiplied by 9 times diameter, or plus additional length required for Bentup bar. So as you can see that for Bentup bar we are getting the answer 3.198, which is greater than the length of the straight bar. It means our calculations are okay. Thanks for watching this video. If you found this video useful, please hit like and subscribe to my YouTube channel Civil Engineering Hub.